Many types of systems can be represented with a causal loop diagram. A causal loop diagram in WinAD consists of nodes and lines connecting those nodes. Each node is a variable, and the lines represent relationships between two variables. Once we define that information within WinAD, we can run a simulation to see how the value of each of these variables changes over time. Let's create a new project. So we're going to click on the New Project button within WinAD. Let's name our project. And we're going to put it at a location where we have full read-write access. So we're going to navigate to C/users/public, and we have a folder there called WinAD. So let's go to that location. And within that location, let's put this into a new folder called bank. So this is the name of our project, the location of the project folder, and we're going to have a dictionary document and a state model document. And for this state model document, we want to select type causal loop. So for this type of project, we're only going to use diagrams. We're not going to use any tables in our state model, so just select diagrams only. And let's click generate. And we've generated our documents, so we should be able to choose open project. We see it has been added to our list of projects at the top. We're going to double click, and now we have our empty dictionary document and our diagram document for drawing our causal loop diagram. So let's start our system model by adding a deposit variable. And we're going to add a bank account variable. We're going to get these lined up a little bit better here. And now let's add a relationship between those two variables by drawing a line between them there. And we'll just leave displayed as empty because we don't need to display any kind of relationship name on the line. So we have our two states, a connection between them, and we're going to merge this information into our data dictionary. When we do that, we see three entries were created, one for the deposit, one for the bank account, and one for the relationship between the two. So let's add some details behind our variables and relationships. So if we click on the details button for this deposit, let's give it an initial value of 100 with a minimum of 0 and a maximum of 1,000. And then for bank account, under details, let's go initial of 1,000, a minimum of 0, and a maximum of 10,000. And for our relationship line here, we'll go to details, and we're going to select the variable bank account equals bank account plus deposit, and then we'll go bank account equals, and we'll apply a function digits, and what that will do is it will take the value that's in bank account and turn it into a dollar and cents format. So once we have that done, we'll click OK. Now that we've defined our variables and relationship and equations in the details for that relationship, let's convert these equations to a script using the built-in scripting environment within WinAD. And now we can run a little simulation. So if we go to the simulation screen here, and we're going to reset, just in case there was some previous results, we can clear those out. So what we're going to do is we're going to start with a increment 1 with an increment count of 10, using an initial value for deposit of 100 and bank account of 1,000. We're going to build our script, run it through those 10 increments, and put the result into this file. When we click the Run button, it's now completed. If we look at the Edit button, we see the results here. Here is our 10 different increments from the initial with $100 deposits, and we see our bank account accumulating that over time based on those equations. Let's cancel out of that and come back, and let's do this a second time. Let's change our deposit to $200 and let's run it again. And now let's look at the results. And now we see we have a run count of 2. So if we look at our first set of increments, we deposited $100 each time. This was the result to our bank account. And the second time we started here and we deposited $200 each time, and this was our end result in our bank account. Starting with our initial 2 variables and the relationship between the two expressed with a couple of equations, we've built out our model. So for example, over time, we can accumulate these deposits into a variable called accumulated deposits. We can withdraw information from our bank account with this withdrawal, and over time, we'll have a variable called accumulated withdrawals. Likewise, there may be a service charge for our bank account. We can, based on an interest rate, have earned interest from the bank account, and that earned interest rate can increase the actual amount of money in that bank account. We might also have income tax based on a tax rate, and that income tax is based on the earned interest over time, and over time we can accumulate the amount of income tax that we're paying, or the amount of interest that we're accumulating. So as we add equations to all these relationship lines and generating the snip of code for those equations, we now have the environment set up where we can simulate this entire little system. And we do that again from the simulation window. So now let's run our simulation where we're going to use a 5% interest rate. Let's go 0.5, and we're going to make a $100 deposit each year and withdraw $50. And we're going to run this simulation over a course of 10 years. And so we're going to click Build and Run. That's going to, over 10 increments, run through our equations and update all the results in this simulation output.data file, and then we're going to graph it, put it out into a chart here. So we'll click the Run button, and here we see the chart. So let's expand this out a bit, and we can see over our 10-year period, this was our earned interest, our deposit amount, our withdrawal amount, our income tax amount, and we see the value of our bank account and how it changes over the course of these years. It might be interesting to see what happens to our bank account over time as the interest rate changes. So for example, let's change this to a 7% rate and run the simulation. And when we do that, we see the new account balances. Or if we do a 9% rate and then run it, again, we see the new account balances. We can also map the same information out in different ways. For example, if we do line charts here, we can see our different account balances based on the interest rates of 5, 7, and 9. Or if we go to the accumulation panel here, here we have an accumulation of just the last run, and we see how the different components of that get mapped out over the course of these 10 years. To summarize, WinAD makes it easy to create a causal loop diagram with variables and relationships connecting those variables, where equations are entered into the relationships that affect those variables. You can apply that to virtually any kind of system and then simulate it. For example, if we go and open up, here's a demographics example where we have births and deaths and various people at different age brackets over time as we run that simulation.